problem. Hi, my name's Tessa Ternullo. I'm a first year here at Penn State, undergraduate material science and engineering.
Nice to meet you. So you know my name, I'm Jamesa, and I graduated from Penn State from the Material Science and Engineering Department in 2019. So I came to Penn State for my graduate degree. Dr. Wolf was my thesis advisor, and my research was on thermal and environmental barrier coatings for commercial jet engines, and specifically how they interact with things like sand or dust that are ingested into the engine during operation.
You did undergrad physics for your major, correct?
Yeah,
What about material science specifically made you want to kind of specialize into that for a PhD?
I think material science, I think the reason why I like it so much is because it's so interdisciplinary. And the fact that I knew that because when I became a physics major, I didn't necessarily know what I wanted my career to be. And so I thought physics would be a good foundational thing to study no matter what I went into in science or engineering. And material science and engineering, you know, like for example, in my current job, I use a lot of chemistry. I work in an aerospace field, so I need to know a little bit about aerospace and aeronautical engineering. While I was there, I had friends who worked on metal materials for nuclear waste materials recycling. Had friends worked on biomaterials. So I think it just gives you a wide range of options. And that's what really attracted me to material science. And specifically when I started working on high temperature materials, because who doesn't love like making something really hot? I think that's also what got me really excited about material science and engineering.
Did you ever think that you'd be working for NASA or working on jet engines when you were like growing up, or did you have a completely different idea of where you thought you were going to be?
No, I had no idea I would ever do the work that I'm doing now. Growing up, even though I loved science and math, especially math, I am an artist by nature. And so when I first went to college, I was actually a studio art major. Then I was pre-architecture, and then finally I landed on physics, and that's what I ended up getting my bachelor's degree in. But so yeah, I always thought I would be some type of artist, and it's funny how life works out.
That's so cool. Like the intersection between MatSE and like any STEM in art is actually a lot more than people think of. I know when someone says like, "Oh, you're an engineer," or "I'm an engineer," people always think like, "Oh, you're just like slumped over a desk pushing out calculations and sending off reports." But I mean, like even here in the MatSE department, we have like the materials visualization competition. I feel like art is especially really interconnected here at Penn State and with engineering and even like around
Oh,
campus. Yeah.
oh yeah, absolutely. So when I was at Penn State, that's actually where I first learned how to glass blow for the first time. We have people here who love doing woodworking. We have a center band, so a lot of people who play different musical instruments. So I think it just having a creative hobby really fuels your mind to think outside the box when you're trying to come up with new and innovative things.
When you were at PSU as a PhD student, did you engage in like the arts extracurricularly aside from glass blowing? Was there anything that you particularly liked about your time here?
Yes. So I was able to do, and I forget what the program was, but we were able to do wheel thrown pottery classes over in the hub. So doing those were really fun. And then even just outside of the university, like I also know how to sew and crochet and do things like that. So during grad school, I actually made a lot of clothes and did a lot of sewing.
Cool. Was there like anything else, any other skills you picked up during your time at the university that you carried with you over into your career and later on in life?
I think the main skill, and maybe this is a cliche because, we're all in grad school or in some type of PhD program. I think we all learn this. I think the main skill, honestly, even though I thought I was a pretty good writer coming into grad school, becoming a better writer, I think has really helped me. Granted, I'm still in a research field where you have to be a good writer, but just learning that skill in grad school and how to analyze data and communicate what you're trying to say effectively, I think also was a huge benefit, especially, I don't know if you've ever done it, but like, for example, the pitch competitions that they have over at MSC, I did that one year and I came in third place. Like knowing how to communicate your science effectively to like a general audience um, to let them know why it's important and why you're doing what you're doing. I think that's one of the major things I learned.
Do you have a favorite memory that you have either like within the program or around Penn State that you just you just keep it there because it's so cool or you like it so much?
Oh, there's so many. I loved grad school. It was so much fun. I think my favorite thing that I did almost each year in grad school was me and my roommates, we would always host a big Friendsgiving at our house. So I think one year we easily had 70 people in our house at once. Like there was MatSE people, there were people like say from geosciences because I had geoscience roommates, so other people from EMS. And I don't know, I just really love cooking for people and having bringing people together. And so if that's the main thing that I've actually also carried that tradition with me, like I still host big Friendsgivings. Those were just awesome. And then I loved going to the end of the year banquets. Those are cool. Just get a little dressed up and, celebrate our friends in MatSE.
Yeah, I signed up for the MatSE banquet. I've never been before, but I heard they're pretty good. I know that we've had like different experiences going through the MatSE program because I'm an undergrad and you went through it as a grad student. Like, what was your favorite thing that you learned that was like MatSE specific? What was something that you saw and you were like, oh, that's so cool? We had to learn about batteries, and I, my mind was just blown that even that was like a material science issue, right? What was a class or a topic that like really caught your eye or that you were really interested in here at the MatSE program?
So when I came into MatSE, again, I was a physics major
Yeah.
when graduated from undergrad with physics, went into MatSE. So I was coming in basically, and before that, like I had an internship where I was working on material stuff, but in terms of basic materials, specifically materials knowledge, I really didn't have. So when I was looking at the graduate school classes, I knew that we would have to take graduate level crystal chemistry. So what I did is I actually took undergraduate crystal chemistry the semester before with Dr. McKinstry. And oh my gosh, learning the different crystal structures of different jewels and gemstones and why they're different colors. Like learning that sapphire and ruby are both alumina, but just doped with different things to produce their color. I was like, oh, that was I think that was one of my favorite things that I learned, like the crystal structure of emerald, beryl, and just learning how the bonds between different atoms create these different structures that result in all of these cool properties. So I think taking crystal chemistry for the first time, undergraduate crystal chemistry, was awesome and it really prepared me for everything else I learned.
Makes me excited to take it next semester. After you graduated from the PhD program, after you defended your thesis and got your doctorate, did you like immediately get picked up by NASA or like what was your path from MatSE here at Penn State to where you are now?
So to take a step back, the first time I came to Glenn was
Mhm.
in 2014 as an undergraduate intern, right when I graduated from undergrad. And that's when I first really got an experience of what Glenn is and the kind of research that we do here. And so that was always in the back of my mind when I was applying to fellowships during grad school, my first or second year, and there was a NASA, specifically NASA Aeronautics Fellowship that I applied to, and it would be sponsored through Glenn. So that's how during my graduate study, the fellowship requires that you come to the NASA Center in my case, it was like every summer for 10 weeks to do your thesis research. So I would be coming during the summers, in the branch that I'm still working in now, getting to know people. And, I was letting them know, hey, this would be really cool to work here when I'm done. And it was the summer before I graduated that my branch chief told me, hey, we have a pathways position that's going to be opening up. Would you be interested in applying? And I was like, sure. And so by the end of that summer, I had applied for the pathways position in my branch. I got it. And so by that November, I came back to get sworn in as a civil servant. So for people who don't know what the pathways program is, it's a hiring program where you get hired into the federal government as a full civil servant while you're still a student. And then when you graduate, you're converted to, a full time employee. So I became a pathways student. I think it was a year before I defended. So the nice thing about that is by the time it was time for me to defend and graduate, I already knew what I was going to be doing when I when I defended. So, and even before I defended, I moved to Cleveland permanently May 2019. I defended September 2019. So I was already working full time even before I converted because when I came, my thesis research was already associated with the project that I still work on now. So I could work on my thesis as my job, and that was super nice. So again, that's the nice part. My path was already lined up by the time I got that. So when I defended and graduated, it was just I took maybe like a week and a half off after graduation, and then it was just back into my lab to do what I had already been doing.
That's like amazing that you're like, yeah, this is what I want to do. And then like you did that. Like you went out and you reached out and you grabbed it and you held on to it. And it's like you do this for like a living now. That's actually so cool. Do you have like any advice for people who want to pursue like a MatSE career in NASA?
I would say take any opportunity you can to meet as many people as you can because usually those people hear about the upcoming opportunities sooner than the general public do. And so you sort of have a leg up saying, okay, this opportunity is coming. I know I'll have my resume prepared for this specific thing. So then by the time it's there, I can go ahead and submit it. I've had time to prepare it and look it over. Um, I would say internships are a great opportunity to get to know people, get to know the different types of research that are happening here, and figure out if it's something that you really want to do.
Do you have any advice for people pursuing a doctorate degree in MatSE?
Yes. I would say in general, make sure that it's something that you really want to do because a PhD is typically, so it took me 4.5 years to finish mine. I had friends who've taken 6 years to do theirs. You never know, it might even take you longer depending on certain circumstances. So you really have to know whether research is something that you want to commit your life to for that approximate amount of time, and also what you're researching, make sure it's something that you're passionate about or it's something that you really like. And I think that goes back to making sure that even before that, you're getting as many opportunities to do research that you can, or try and um, work at a different institution as many times as you can to get a feel for what you really like, because you have to really enjoy it in order to devote your time to it because it's hard. If getting PhDs were easy, everybody would be doing it.
I once asked one of my professors who teaches one of the intro MatSE courses, like, do you have any advice for me? I'm interested in getting like a PhD. And he said, don't. Because he's like, it's so much work. Some people go through it and they're like, "Ugh, I regret everything." Some people really like it, but I just had an okay experience. So I'm like, oh, it seems to me like really there are a lot of people who go through PhD programs, and maybe some of them are there because they really like what they're doing, but others maybe just haven't found the right opportunity for them yet, right? Is there like, are there any like tips that you have for someone kind of, I don't know, doing some soul searching before fully hunkering down into a program?
I would say it's okay to not rush into a PhD. Like if you're sitting here in this moment where you're like, okay, I think it's something I might want to do, but I'm not sure. By all means, take the extra time to again, maybe do another internship related to it to see if you really like it. Work another job. I myself, after I did my internship at Glenn when I graduated, I didn't go directly into a PhD program because I knew I wanted to do one, but I didn't know what I wanted to study, nor did I know where I wanted to go. So I had already had lined up after that. I did a Fulbright scholarship in Germany to work on materials research. So I told myself, I'm like, okay, during this, I'm going to get full on. I'm going to be working on materials, specifically high temperature materials, which is what I thought I already wanted to do. I'm like, okay, I'm going to work on this day in and day out while I'm here to truly like figure out, do I like high temperature materials? And if I do, this will be a great experience. And while I'm there, I'll start applying to grad schools and figuring out where I want to go. So taking that extra time was awesome. It gave me an opportunity to go forth on this wonderful scholarship that I had and make connections in another country. And again, like really hunker down into materials research. So that was about, it was, yeah, so that was graduated May 2014, August 2014, went to Germany, came back August 2015, and that's when I started grad school at Penn State. I have friends who they did undergrad, they went to work somewhere, like worked an actual career for a few years, then went back to grad school once they were ready for it. So it's okay not to rush into it because again, once you're in it, you're in it until either if you're in it, you decide, hey, this isn't for me, or you're in it and you make it to the end. You're in it once you're there. So might as well make it something that you're gonna enjoy for the majority of the time.
It's actually really helpful. A lot of the culture I've seen in my peers is like, oh, well, I gotta plan out like the next 20 years of my life. As soon as I finish this degree, I'm gonna go to this school and I'm gonna get this PhD and then I'm gonna work at this company. And I'm like, do you have room to breathe? Do you have like have you taken a step back and have you like looked at everything? And that wasn't really like I hadn't really thought about it in those words, but that's like a beautiful way to articulate that. It's really nice to know, like now that you've like gone through everything, you can look back and say like, oh, I'm glad that I took that time for myself.
Yeah, in some ways, I wish I knew what I wanted to do. You know, it would have saved me time in undergrad and honestly in undergrad a little bit of money. In terms of like, oh, I had to go to school because one of my semesters in undergrad, like I started at a completely different school my freshman year. And then after that, I actually took a semester off completely from school to like work at a Macy's because I'm like, all right, let me not rush into another thing. I'll work for a semester, make a little money. Let me figure out where I want to transfer to and go from there. So that was a semester off that I took. And then actually one of my semesters I took off to just completely work an internship. So no classes, just go to another state, work an internship, start getting science experience. So that actually set back my graduation a year. But at the end of the day, that was valuable experience that I got. Great internship opportunities, great opportunities living in different states. Um, so at the end of the day, while it's nice to know I say kudos to anybody who already has their path figured out. Like, you're passionate about it, this is what you want, but most of us don't, and that's also okay.
Yeah. Especially since like MatSE is such an, like you said earlier, it's super interdisciplinary. There are so many things that you don't think are MatSE that use like all the things you learned from MatSE. And that's so cool.
So a few of the projects that I work on at Glenn currently, a couple of my main projects are still related to making better protective coatings for gas turbine engine parts. Specifically, we're looking at parts that are in the higher temperature sections of the engine that are going to be experiencing the most mechanical and thermal stresses. The whole reason this is important is that ultimately we want to, currently a lot of engine components are made out of nickel-based superalloy components. Those components are slowly being replaced with silicon carbide-based ceramic matrix composites. But those matrix composites are really susceptible to corrosion via high temperature water vapor, which is a standard gas combustion byproduct. And so because of that, we're working on what's called environmental barrier coatings to protect those components so that those components are much lighter weight than those nickel-based superalloys, so we can make our engine lighter, and they have higher temperature capability, so you can let your engine burn hotter to improve fuel efficiency. So working on those coatings, again, my thesis work was related to looking at those coatings interact with dust particulates like desert sand and volcanic ash. So that's something that I'm still working on. And right now I've moved more into making better test methods to assess materials in those environments. Um, and I have projects related to improving thermal insulation materials, both external and internal, for thermal protection systems, mostly focused on things like atmospheric reentry materials. Recently, I got into something which I think is super cool, related to what's called in situ resource utilization. So there's a big push right now looking at uh, the fact that when we go to other planetary bodies like the moon or anywhere else in our solar system, launching things to space is very expensive because every amount of mass counts. So in situ resource utilization looks at it from a perspective like, okay, what can we already use that's there to create materials and other feedstocks that we can use to either make things, make infrastructure, make fuel, that sort of thing. So I'm working on the materials considerations from an ISRU process called molten regolith electrolysis, which is essentially you're running an electrolysis cell on molten lunar regolith to reduce the mineral species into metals and oxygen, so that now you have an oxygen source in situ and you have a metal source. You're reducing things off like iron and silicon and aluminum, which you can use to make, for example, silicon making like solar panels, and then aluminum making wires and also structural components. But that process usually has to run at 1600 degrees C and higher. And there's not too many materials you can have in contact with a molten glass, which is essentially a molten glass at those temperatures. So I've been working with one of my friends who's currently a graduate student on looking at the materials considerations of that. What materials can we use that can be in contact with this molten glass long enough to make these processes efficient to extract oxygen in those metals. So that's been super fun as well.
So it's still like you still have that high temp application for like materials. That's so cool.
Yeah.
Yes.
So my branch specifically, so my branch is
Mm-hmm.
the environmental effects and coatings branch.
Mm-hmm.
And we are in the materials and structures division here at Glenn. Glenn, we have a expertise, we've had it for decades in materials and structures for extreme environments. So extreme environments can mean very high temperatures, cryogenic temperatures, different pressures, oxidative or corrosive environments. So For a good portion of a lot of aerospace things, it can mean high temperature, which is where my interest in high temperature materials comes in. But really, in our branch, we can approach materials from all those different perspectives and test them to understand their behavior in those different environments, their properties in those different environments, and how we can make better materials for those different environments.
How do you how do you test those materials in those environments? Because they seem kind of extreme. Do you have like a very specific high-tech setup, or is it kind of like a MacGyver scenario where it's like, oh, if we just blast this and then get the measurements really quickly, we can test them.
So it depends. You can do it as simply as like, hey, I need to measure the thermal expansion of this material as a function of temperature. Like that's important data. And there's plenty of ways you can do that. You can do that with dilatometry. You can do that with high temperature XRD stages, which is I do a lot of work on high temperature XRD stages here. You can look at the kinetics of an interaction. You can do that either simply literally furnace heat treatment, or you can look at it, you can go a little bit fancier, high temperature X-ray diffraction. We have characterizing the microstructure of material before and after it's been exposed. We have SEMs. I do a lot of work here in our burner rig facilities. We use those burner rigs a lot for our materials assessment for gas turbine engines, but those burner rigs can also be used, as we've done recently, looking at thermal gradients through thermal protection system stacks. Like you just take the stack, put it in front of that burner. We know what the surface temperature is, and then looking at that thermal gradient with pyrometers in the middle of each layer, not pyrometers, excuse me, thermocouples in the middle of each layer of that insulation stack. We have high temperature lasers we can also use those to look at thermal gradients. But as you said, we'll also MacGyver some systems. For example, we have a lunar dust adhesion bell jar looking at, hey, if we take some lunar simulant, we put something in there like a solar cell, which you really don't want lunar dust to get on the surface of because it's going to ruin your efficiency. We put it in that test cell, deposit some dust on there, see if there's different passive and active removal techniques that we can use and how those work. That's a bell jar that was built here. So it depends. Like if you're simply just looking for properties as a function of temperature, we can do that. We can do certain rigs mechanical properties as a function of temperature. We have, as I said before, water vapor is a huge concern for some of these gas turbine materials. We have steam furnaces that we've MacGyvered and built here that we can put materials in, have flowing steam, measure things like their oxidation rate in steam environments, how they degrade in those environments. So yeah, it can be a very simple test, or it can be something that we have to make up for a specific thing that we need to observe. So yeah.
I keep saying that. I keep on saying that's so cool, but it really is. This is like some really interesting stuff that you're a part of. That's like you're so lucky. It's that's so cool. I know you mentioned material coatings, and when you were talking about putting the different material, like putting them through all these really cool like heat chambers or like blast chambers, you talked about them as like layers. Is it not just one thermal coating, or do you have a bunch that you put on top of each other?
It depends. You can have, for example, the coatings that I talked about for the gas turbine engine parts, those can be multi-layered in the sense of like you can have a layer that's supposed to be there to match closely to the thermal expansion of the substrate, and then a layer for some other purpose. Or they can be single layered if you have a material that meets all of your requirements for that coating in terms of the top coat. For thermal protection system stacks, they're usually different layers of insulation, and each layer of insulation provides a different capability. For example, like the outside is typically in most thermal protection system for most reentry vehicles, you're looking at like a carbon silicon carbide composite panel on the outside. Then you might have a layer of insulation right after that that's maybe thinner, but has high temperature capability, but it's really heavy. So maybe your layer under that one is something that might not have as high temperature capability, but much lighter weight. So you can make it thicker. Yeah, it really depends on the application and the requirements you have.
Your work sounds really awesome. What's your what does your like day-to-day look like in the office? Because I don't think you can be blasting materials in a furnace every single day, right?
Um, well, if I have a lot of tests I need to get done, I could. Most days I am in my lab. This week I actually came back from I was in Japan for almost 2 weeks. So the end of last week and then this week I've mostly just been getting back into the swing of things. So that means I was on my computer for a good portion checking emails, and then I'm actually preparing for a conference. The conference isn't until the summer, but the draft slides for it's essentially a tutorial presentation I'm giving. They're due next week. So I've been on my computer a lot recently working on those slides. I have a couple of co-authors on papers that they've written, but I'm a co-author on. So I've also been reading those papers that they're giving me so we can prepare those for journal submission. I would say my day to day, if I wasn't in this period of doing a lot of computer work, usually my day to day is I'm testing materials, synthesizing new materials. Um, and then in between that, usually I'm either doing, writing papers, reviewing papers. That is something that I also do, like review other people's papers. And if I'm in the process of preparing for a conference, I'll also be making slides.
So a lot of writing. That's actually kind of surprising. I thought if you were like in a research position, you would be doing like hands-on lab work all the time, but it makes sense because you have to like write up your reports and your experiments, and if you do grants, you ask for grants, right? My question for you is, because writing seems like such an intensive part of your job, did you feel that technical writing was more helpful for you for that, or creative writing?
I think I think a little bit of both. Um, I think if as you're writing papers, it's still telling a story. So just presenting, like writing a paper as a data dump, that's not necessarily helpful in regard to understanding why the data was important and what it means. So I say both technical and creative writing are super important.
School, like the higher levels you get, because going from high school for me to undergrad, it was like, oh, you have this strict schedule and you have these jam-packed classes, and then you go home and then you study until like 10:30, and then you like go to bed, right? And then I get to college and they're like, yeah, you can show up if you want. It's not required. Yeah. That was like a very, very big switch. And then looking at all the people I know who went through like grad school, it's not like, oh, you're gonna be in classes all the time. They kind of a lot of them are going through a transition now. It's like, oh, well, now I'm also doing research and forming my own ideas and figuring out how to like work in a lab where I'm not necessarily working under someone, but I'm coming up with my own ideas and I'm experimenting on them and I'm in charge of writing my own paper, right? And then now you gotta also get out into like the not necessarily the non-academic world, but the non-college one, right? Where everyone has, oh, well, it's not like you have a class to take or you have like a primary investigator who's going to be looking over everything you do. But now it's like you are your own, you know, teacher. You are the only person responsible for whether you show up to work that day or what you're going to be doing in there, right? So it's like, how do you just learn to do that transition? Do you learn to, I don't know, live life like outside of living in a dorm or on campus, you know?
So it was interesting. My thesis advisor, it was the day of graduation, and we had lunch before because my graduation, yeah, the graduate school graduation, it was that night. So like early in the day, we had lunch together before I had to go back to where I was staying with two other friends who were also graduating and start getting ready. And so we were at lunch, and we were talking about my journey and all these different things. And he was like, "How did you do all this? Like, did you just decide?" I was like, what other choice is there? I made those decisions because I was like, okay, this looks like a good opportunity. Why shouldn't I take it? The worst that's going to happen is, oh, I find out that I don't like something. All right, I'll try something else. I'm still in school learning. And if I don't do it, then, maybe I would have regretted it, maybe not. But at the same time, I'm like, what other choice is there? This is an opportunity and I need to take it. So, going along with what you were saying, like making these transitions, everything might seem scary until you do it, but you never know. It's something that I always like telling people. It's like the worst, or like when someone's debating if they should ask a question, like to whomever inquire about something. I'm always like, well, the worst thing that could ever happen is someone say no, and then you just move on and figure out another solution. Um, in my mind, that's like how I've always operated because there was always, well, once things started to materialize to me in regard to what I wanted to do with my life, and especially when I decided to go to grad school, or even before that, it's like, what's my next objective? That's what I'm going to accomplish, or that's what I want to accomplish. Okay, what steps do I need to do to take that? Okay, once I figure out those steps, they make sense. I know the process to do them. What other choice do I have but to do them? Um, so as you find yourself deciding what you want to do and going through life and getting to these critical points where you're like, what's on the other side is unknown and it seems scary. Well, on the other far end of that, if you have an end goal and that's the only way or one of, the few ways you're going to get through it, what other choice do you have? If your end goal is also on the other side of that, but just maybe further away than what you can see immediately, the decision you have in front of you right now.
Yeah. Okay. I feel much more secure about the future now. At least for what I can do. That yeah, I'm gonna keep that with me. Thank you, Jamesa. I have one more question for you, if that's okay.
Yes.
So looking back on like everything you've done, which I know a lot, right? Um, even in like your life and like all the actions you took to get where you are today, what do you think is the most prominent thing about yourself that got you into that chair in this Zoom meeting right now? Sorry if that was cheesy.
No, you're fine. Um, I think the most important thing is I won't say not being afraid of what comes next, because I mean at some level we're all like we're gonna fear the unknown, but I think it's in my case ignoring whatever fears I had and just going for what I thought would be a good a good opportunity for me. Um, because again, I was just like, I want to succeed. This is what I want to do. And so just being able to steel myself to make those decisions that, at one level, someone might think it's, sort of weird or just random. The fact that I went to all these different places just to try and figure out what I wanted to do. But I'm like, hey, they're paid internships. I'm getting paid to do this awesome project. Why wouldn't I go do this? If I don't like it, it's not like I did it for free. It's like I still got something I learned valuable skills. Um, so if I would say anything, I would just say that like being able to push forward into the unknown for a good opportunity and just seeing what happens.
Have a good one. Thank you for talking with me.
Absolutely. Have a great day, guys.